Okay, let's get this done. There's only a couple problems to do. Do you remember improper integrals? They were they were integrals if we wanted to integrate 0 to infinity. Maybe let's make 1, actually, of like 1 over x dx. Remember that we did those? Let me refresh your memory. Okay, guys? And then what we would do is we would change this from 1 to t and put the limit and let t go to infinity. Are they particular on the exam about this? For your response? Yes, they are. If you don't use the right notation, you will not get your points. They do get very particular about having the mathematics correct. Now, I've never seen them grade that. I've graded the BC exam, but I've never graded that one. Anything like that. And then this would be 1 over x dx. So that would be the limit as t goes to infinity. What's the antiderivative of 1 over x? ln of x. From 1 to t. Now, these are like series, the infinite series. This relates to chapter 8. That's this type. It's a type 1. So it's the limit as t goes to infinity of the log of t minus the log of 1. Well, log of 1 is what? And this is the log of infinity, which means it's infinity. Remember the integral test. Okay. These are integrals which have infinity as an upper limit, lower limit, or possibly both. The other types are a little bit different, but it's done exactly in the same way. So this is just saying if you have an integral from a to b, you can look at it as the limit from a to t, and we'll look at this from the left side of b. Or if I'm coming in from a, the bottom limit, it's the right side of a. You think about it, why would it have to be the left side of b? Maybe it's a vertical asymptote. Here's b. So you're going to integrate from a to the left side of b. Does that make sense? Where this other one, if I'm looking at my axis here, then this would be the a. You have to come in from the right side of a. I don't think they're going to give you one of those one-sided limits. They're probably just going to give you a regular old problem. And sometimes you could be integrating like from negative 3 to 3 of 1 over x. What about that one? What about that one? Well, I don't know unless I do it, but you have a break where? At x equals 0. So you have to break that into 2 integrals. That's the type 2. So the first one was letting your upper value or your lower value go to infinity or negative infinity, and the second one is actually with vertical asymptotes. Now be careful, because a lot of you like to do the p-series on these vertical asymptotes. You can't. The only ones you can use the p-series on are these type 1. P-series is for type 1 only. So I'll see some of you try to do that, and you can't do it. That's where the limit is going to infinity rather than a value. These are horizontal asymptotes. Yes, we will take the whole week before the exam. And I mean the week before the exam, because once we get into exam week, half of you are going to be gone on any given day. So I will focus on that week, and we'll do study sessions. I don't know how many other study sessions you need. We have, I think, 200 AB students, and they come. So we may have to distribute ourselves so we can all take care of them. We do have the forms for some of the days. So that would help with that. But the BC is always a smaller group. Okay, should we do a problem? This one. And normally, when I look at it, I don't even think of improper integrals. I'm just thinking, oh, I just have to integrate that. But where do I have a problem? At x equals 2, I have a vertical asymptote. I don't exactly know what it looks like. I just know that when I come into 2, and can I come in from the left side, or do I have to come in from the right side, by the way? I have to come in from the right side, because the left side, I'm going to end up with the square root of a negative number. So you do exactly like what we did before. It's the limit. We'll make that t in this 5, and we'll let t approach 2 from right side. I almost said it wrong. No, I want to save a little time. How would I rewrite that so we could integrate it? Well, it's this, x minus 2 to the 1 half, right? And all we have are that finite list of integrals that we can do. It's all we've got. Yes. So I have to recognize that as the power rule. It certainly doesn't look like sine or cosine. So it's the limit as t approaches 2 from the right, and it's the integral from t to 5. And yeah, we'll be picky about the notation because we want you to have it. Okay, and so then we're just going to integrate this. The limit as t approaches 2 from the right, this will be x minus 2 to the what? Go up 1. Yeah, up 1. It's 1 half. Divided by 1 half is times 2. Evaluating at t and 5. There's no guarantee these converge either. It's kind of nice having done chapter 8 because now when we talk about convergence, divergence, you know what I'm talking about. There may be a number there, there may not be. So we're going to put in 5. So I'm going to get 5 minus 2, so I'm going to get 3 to the 1 half, and that's still times 2, minus the limit as t approaches 2 from the right of 2 square root of x minus 2, because I prefer to look at it that way. So this is 2 times the square root of 3. And if I come in from 2 from the right, you can always do right-hand-sided limits, unless it's too many wiggles. So I can just substitute that in there. Sorry, I should have used t. T minus 2. Yeah, that would be a little problem. So it's t minus 2. So I put 2 in. 2 from the right. What's that going to? 0. So this is 0. So it does converge. But don't try to use the p-series on this, saying that p is 1 half, so it diverges, because this is not the right kind of integral. The only thing the p-series works for is like going from 1 to infinity. It does not work when you're looking at a vertical asymptote. So maybe I shouldn't write that. The p-series does not apply. And the reason why I talk about it is I remember seeing that on a lot of papers. Then we have one more to try. Oh, but this one's going to be tough. The next week, I'm sorry to do this to you on a Monday, but we'll have a test Monday, Tuesday. Yeah. Yep. Yeah. Chapter 5. Then we're going to do chapter 6, which is the area and volumes with the graphing. Remember when we rotate graphs and cross sections? And then we will do the polars and do areas for those. We won't do volumes for polars, but we'll do areas. You'll find out about polars. I wish you didn't. Now, they have not had a free response polar question in many years. And I said last year, I was sure, I guess I have two, I was sure that they would have that. But nope, they haven't. So I think this year, it's either a vector polar. It's one of the two. So know them both and you'll be fine. Okay. I'm missing a theorem on mine, but I don't know why. So let's do that one. And is there any problem with the log at my endpoints at all? Or in between? What's the log? Can't do the log of 0. So we will do the limit as t approaches 0 from which side? The right side. Good. Uh-oh. How are we going to do that integral? We did it in class. I've memorized it. We have to do what? Integration by parts. So let's just do integration by parts on the side. We will not put limits in. Now, do you remember how to do this? Now, tomorrow, we will have a really short quiz, and it has one integration by parts on it. And, well, if you've been working on your homework, it shouldn't be a problem. And one partial fractions. Yep. That's the partial fraction. Yeah. All you have to do is find the two fractions that added up to give you that answer. That's not, it's just weird. This is hard. Now, remember, which one do you want u to be? Remember, I want u to change form if I take the derivative. So if I let u be the log of x, and that changes form, that becomes 1 over x. So u is equal to the log of x, then du is equal to 1 over x dx. Then this part, the other part will be, because all we're trying to do is undo the product rule. That's dv. That makes sense? That came from the product rule? That's what the u times v is. So if dx equals dv, then v is equal to what? X. Okay, so we're going to take u times v. So it's going to be x log x. If you want to memorize this one, because I've seen it so many times, be my guest. I've memorized it. And it's going to be minus the integral of v du. Oh, yeah, x times 1 over x dx. That's right. It's x log x minus the integral of 1 dx, which is just x. But I've memorized that. So, going back here, now we have the limit as t approaches 0 from the right, and I've integrated that. So it's x log x minus x. Trying to switch these limits of integration when you do all that, it's just hard. It's a lot of bookkeeping. I don't think you necessarily need to do that. And this is t, and this is 1. So we put that in, so it's 1 log of 1 minus 1, because the limit does not affect that constant. And then we're going to put in, we got a different problem now. Then we're going to do the limit as t approaches 0 from the right side of x log x. Oh, sorry, t log t. Forgot to make that switch. I'm just thinking ahead. Minus t. Well, we can do some of it. We can't do all of it. Not easily. What's the first one going to give me? This is going to give me what? Because you plugged in t here and here and there. That's 0 minus 1. Let's go ahead and do what we can do. I can do the t approaching 0 with this one. That's okay. But I'm still left with this limit as t approaches 0 from the right of t times the log of t. Why do I say that's a problem? No? Because this is 0 times what? Oh, maybe it's what you're saying. 0 times infinity, that's indeterminate. But we remember another way to do it. Whose rule? L'Hopital. L'Hopital. You have to go to the hospital because you're in trouble, right? I'd try anything. Okay, that's not a fraction. Which one do you want to put in the denominator, the t or the ln of t? Now, it doesn't matter. I mean, when you try one, if it doesn't work, you try the other. But to me, putting the log of t in the denominator is kind of tricky. Can't I do this? It's the limit as t approaches 0 from the right side of the log of t. If I put t in the denominator, that's 1 over t. Is that okay? Then if I put 0 in, that's negative infinity. That's infinity. You can't have infinity over infinity either. I'm sorry, what? I just put the t in the denominator. If you don't believe that's the same thing, multiply this by t and this by t. That's the same thing now? This one is 0, and this one we could do too. The only place I have an issue is right here with this t times the log of t. And then you would say infinity over infinity to get the point so they know that you know when you can use L'Hopital. And then we have to use L'Hopital. So I get negative 1 minus the limit as t approaches 0 from the right. Do you remember L'Hopital? Now, we have different chief reader, different question leader. They may want to see that little L, so put it in. I know when I graded it, they didn't care. They cared about this. But you know what changes from year to year? So to be best prepared, I'd say just do both. Okay, so remember what you do with this? You take the derivative of that. What's the log of t? 1 over t. Now, if you guys memorized the log of 1 over t yet, 1 over t is equal to t to the negative 1. No, we're going to differentiate. Take the derivative with respect to t. Negative 1 t to the what? Negative 2. Or negative 1 over t squared. I've done that so many times, I know what it is. If I could say it in my sleep. That and the integral of the log of x. Now what are we going to do? We have to clean up these denominators, so why don't I multiply by t squared over t squared? And I'm going to get negative 1 minus the limit as t goes to 0. That's going to go. Can I go ahead and pull that negative out in front? Sure. And then this is t. Actually, it's not going to matter, because what is that limit? That's 0. It is. You could, if it's multiple choice, you could think yourself through it. When you look at the t times the log of t, and t is going to go to 0, right? See, t is going to go to 0 really fast. This is going to go to infinity really slowly. T going to 0 is going to win out. As you can see, I just proved it. Is that okay? All right, you know how to do this? I had to do a whole bunch of stuff. I had to do integration by parts, and I had to do L'Hopital's rule. So yeah, they could throw it all together. It's negative 1 minus 0. Yep, it's negative 1. I'm missing a slide here. Yes. Yeah, I'm almost done though. Why am I missing a slide? Oh, let's do this one. Oh, you know what? You can't do that example. I don't know why it's there. I mean, we're going to do it, but you can't do it to this. Okay, guess what? Remember comparison tests for series? We have comparison tests for integrals, which should make sense. Because what is an integral? Area under the curve, signed area. So if f is bigger than g, then if I integrate to infinity, then if f is bigger than g, no, g is smaller than f. It's the same thing. But if f converges, let me draw that picture. Okay, f is bigger than g, so here comes f, and here comes g, and we're going to tell you that this one converges. Then what's true about g? It converges. What if g were up here? What do you know? Nothing. Okay, you guys? Trevor? If g is up here, you know nothing. This is one of those where you got to be in the right placement here. So f is here, and then g is smaller. I have that written right? I think I might have it written wrong. Whoops, here's g. F is bigger than g, and if g is divergent, then what would be true about f? Divergent. So all I have to do here is compare this one to something I know. The only thing I know is e to the x. Now, do I know if it's smaller than that or bigger? Well, do you want to do e to the minus x instead? Well, see, if I compare it to e to the x, e to the minus x squared looks like this. Because as x goes really big, it goes to 0. E to the x, unfortunately, looks like this, which diverges. This is smaller than that. So you know what? I know nothing. So I don't want to do that. It was a good idea, but somebody else then came up with maybe something else. What else could you compare it to? No, it's only for limits. We're not doing a limit. What might this be under? If I could show it's under a convergent one, then it converges. What might be this function? Not e to the x. You're really close. The ln x looks like that. E to the what? Negative x. We can put it on our calculator. We can look at it. So now this is one of the type 1s again. But I just really want to find out if it converges or diverges. So I know that this, and you might say, how do you know that? I'm going to graph it. It is smaller than this one. Does that converge or diverge? Well, I don't know. It's the limit as t goes to infinity from 0 to t of e to the minus x. Let's switch over. Of e to the minus x dx. Now, can you integrate that without a u substitution? If not, we'll do it. Ori, can you tell me what the integral of e to the minus x is? Almost. How do you know if something's an antiderivative? Take the derivative. If I take the derivative of this, I get a negative e to the minus x. I have a positive one, so let's put a negative with it. Now does it work? If you need a u substitution, please do it. So it's the limit as t goes to infinity. So it's minus e to the minus t minus e to the 0. All I care about is, does this converge or diverge? If it diverges, I know nothing. So if it converges, then I know my other function will converge as well, and I can't integrate it. Impossible. And I bring up my CAS calculator if you want, show you can't integrate that. So what is this going to be? Let's write this better. It's the limit as t goes to infinity of a negative 1 over e to the t. Honestly, I can't do it either looking at it that way. And this is minus what? Oh, not minus, plus 1. What does this give me? If t is getting really big, what's 1 over e to a really big number? That's 0. So this limit is 0. This integral converges to 1. Therefore, what's true about that one? All I want to know is, does it converge or diverge? This is smaller than this one. Does that converge? Yeah, by the comparison test. So we just reviewed the comparison test for series. It's the same thing. And then we could, or I could put on my iPad. I've got it on my computer. Should we look at that? Because some of you are maybe not believing that that function really is, oh, this isn't going to work. It really is below that other one. So I'm going to bring up my calculator. I personally like my Inspire one better. I just think it's a nicer graph, especially when I go off to infinity on this one. Now, if you have an iPad and you buy this, which you have to buy in the next 3 days, because the sale will go off, you can do exactly what I do with my screen, but you can do it with the iPad. So if you want to put an integral in there, you want to put the dx in there, you just tap the screen where the x is, and then tap the x and put the x right in there. I don't even think I can do that on this. The thing I don't like, it takes forever to bring up. It also uses a lot of memory. I can just write exactly what I'm doing here, you can do with the iPad. Okay, so y equals, I want e, where's e? E to the negative x squared. And of course, now I have to relearn where all my buttons are, because they are different. If you didn't believe me, that's what it looked like. That's what it looks like. And then we will tab down, so I get down here, and I want e to the minus x. What can you tell? Is the red one bigger than the blue one? Okay, so can you tell if I do that? Yeah. And I can Can I shift it? Actually, the Inspire app works better. There. There. Now you can see, yes, it is above e to the minus x over here, but over on this side, no, it's not. So much easier on the Inspire. I want to take a picture. Here are my pictures. Tools. Screen capture. Then I got to go paste it in there. Okay, should we try the other one? Ooh. There it is. Not as nice. That part is not as nice. I should have them fix it. Okay, there you go. So what about that other example that I skipped? Because I said, I don't know how to integrate that. Can we see if that converges or diverges? What about that one? Okay, guys, just a little bit of help here. Matt, what could I compare that to that I can integrate? What does it look like? If x goes to infinity, this looks like what function? 1 over x, doesn't it? Now, is this going to be bigger than 1 over x or smaller? It's bigger, because that's, even though that's not much there, it's still a little bit more. Right, so it's 1 plus 1 over e to the x. It's still positive. Okay, so it's bigger than this. Remember, we just did this at the beginning of class. Does this integral from 1 to infinity? Oh, we didn't do this one. Yeah, we did. From 1 to infinity, does that diverge or converge? It diverges, remember? When I did it, right up there. We said it goes to infinity. This one is bigger than that. This diverges. So this one diverges by the comparison test. And I'm pretty sure I've assigned some problems that ask you to do that. That's all it's asking you. I don't know why it's on that page. Shouldn't be on that page. It was a last minute add because it's not on your handout. Okay, do you understand how to do the improper integrals? Rolling down. The only thing that's left that's new, we have arc length. That's in chapter 6. And then we have the polars. And I think we might have some arc length with polars too. But you'll see how it works. And then just in on parametrics again, vectors, and the logistic differential equation. That's all that's new that's left. But you have to know the regular diffie-q's because you're probably going to be asked that. So that should feel good because it's only March 7th, right? I'm not cooperating for me, but that's okay. Then I'm going to give you your quizzes back.